So today let's spend our time learning about how online ticketing platform works. And I cannot tell you, but there are so many interesting challenges that are there as I've been just researching. It's just mind blowing. So I will be just using AI, as you can see on the right hand side, to learn. My motivation for from in these videos is just to learn about the systems, because I might not know enough to tell you about the systems, the interesting things that are going there. So it's more for learning, even for me and for you. But yeah, I think but yeah, let's just get started. So I would just give it a basic prompt. I just ask it to behave like a senior software engineer. So I just want to understand the challenges of building a online ticketing platform. So the way we will go is we will just pick up. So today's problem is online ticketing platform. We understand some challenges and we dive into at least one or two of the challenges till we understand everything about that, like everything. And you can always ask your questions. But let's just get started with the online ticketing platform and see what we get. So okay. The first thing, it has already come up, the extreme concurrency. This is the first challenge that we have, which makes sense, and that is that how do you handle so many concurrent users that are trying to enter your website as soon as the event bookings are just starting, right? So yeah, I think it makes sense. And of course, there you might think that there is some queuing kind of mechanism, but I can expect there is much in-depth problems to be understood here. Like, how does that queuing work? How do you assign some ID or queue order to the users to let them in, kind of thing, right? So we'll dive into this problem for sure. I think it's worth discussing that. Then we have the inventory integrity. So this is another interesting problem that we need to understand about, is if two users are clicking upon the same seat, how do you actually prevent them from how do you prevent double selling of the particular seat? You just want that one seat to be assigned to one particular user. That's our goal, right? So how do we achieve that, right? So there are two strategies mentioned here: distributed locking, atomic database operations. And let's dive into these even more. And the bot arms race, as you can imagine, today's world is not ideal and people are just making money by trying to resell the tickets. So you need to handle this. If you were to build a platform, you definitely need to handle those bots who will try to attack your platform and deteriorate the situation even further, even when there are already so many humans that are simultaneously acting on your website, of course, right? So there are fingerprinting captcha and post-sale audits and things like that. And then there are complex front-end seat maps. Yeah, okay, this mostly seems like, okay, I don't think it's worth diving into at this point. Financial consistency. Yeah, I think it's also not what I am right now interested in knowing about, because the problems that have been mentioned above are actually seems most interesting to me at this point of time. So let's dive into this problem a little bit more. So let's just ask the simple question. So what this guy is saying, okay, if you have 50,000 seats, 200,000 fans waiting for the 10 a.m. starting sale, and then you have so many people clicking on the same link almost instantly or almost in the same second, then how do you handle it? So sitting in front of this load balancer, taking to prime relation with 3 replicas. Yeah, so this is the naive approach that is being described, right? If you just try to pass your request to the backend and then try to handle those requests, it just doesn't work like that. It would just crash up server for all the reasons that have been mentioned. You have too many connections to your database. Your servers cannot even handle so much of the network requests, and then your database cannot process so many operations, leave alone the write. You cannot even process the get operations for so many users. So this is a no-go approach for us, of course. So let's move to the other based approach, which is the defense shield mechanism. What they're doing here is you need to stop so many users before hitting your critical mass, right? Your critical piece of infrastructure should be only made available to the amount of users that you can handle, That's how it should be. Okay, and how do we do that? So it's via DNS CDN interception. What is this? So let's try to understand. Okay, so what's going on here is that there is a layer between the infrastructure backend and the users, which is called as CDN, content delivery network. I think the full form, content delivery network. So what's going on here is that as soon as the user tries to hit your website, they're intercepted by a CDN location, which is very close to the user, CDN edge location closest to the user. Then the worker doesn't forward the CDN. We will dive into CDN a little bit more, like how is it able to intercept and all that, but let's assume there is somebody sitting between you and the application servers who's intercepting all the requests that are coming, and those requests that are coming from the users are not actually forwarded to the backend. What happens is that the user is just returned a static HTML page which serves as the waiting room, and the waiting room is basically being maintained based on some tokens that you have been provided. So I think here what has not been clearly mentioned is that how do you allocate the waiting room? Like I think there is something even deeper, right? It says, okay, you flip a DNS switch or in a firewall, heading traffic to this is intercepted at DNS. Makes sense. The edge worker does not forward the request to the origin server. Instead, it returns a lightweight static HTML page for the waiting room, and the user connects via WebSocket to the waiting room service to get their status. You engineer all Okay, so they somehow put the user onto the waiting room, and then user is checking via the service and via some backend service whether they can proceed ahead or not. And you, the engineer, can safely, so you are just allowing 2000 transactions per minute kind of thing without the database lockup. So this limits can be found, and then you have the golden ticket. So when the user reaches to the front of the queue, they are just given a JWT, JSON Web Token, and then they are able to basically get access to the APIs that allow them to reserve their tickets, right? So I have so many questions here. First of all, what is a CDN? I think that is something that we need to understand, right? Then the second part is that how, like this WebSocket part I don't completely understand. Like how are the users being communicated that they are X in the queue at a current moment? This is not super clear. They say it's via WebSockets, but is that the best way? I'm not so sure. So how are users state in queue being initialized and maintained while they are logged in, right? So I think this also comes into the leaky bucket part. So how do the users know? I think this is somewhat we have already covered in the second question. How do the users know they are in the front of the queue? What happens then? Okay, so these are the questions that I think I need an answers to before we can proceed ahead. So as I told you, we will dive into very details of one part of the problems, even if we cannot cover all the problems, but we want to be expert at the things that we are looking at. So yeah, this is the first problem of handling so many people. So CDN, its simplest, CDN is a network of servers distributed globally, designed to deliver content to the users faster by being physically closer to them. Okay, they have massive warehouse, but they also serve thousands of smallest centers near major cities. When your order doesn't come to the central warehouse, it comes to the, I don't know if it's true for Amazon or not. This is all what it's generating automatically, so I won't be speaking anything on behalf of Amazon, but okay, let's say it's anything Amazon or any other web service. CDN are used to cache static files so that your main service doesn't have to serve them over and over. In context of our CDN is much more than a cache. It's a programmable blast shield. Okay, you allow you to run your code on the edge servers. It's called edge computing. When 2 million hit the user doesn't all the way to data centers, it hit the nearest CDN node. 2 million hit your load balancer and game over. Okay, it's 2 million requested edge. The code runs saying too many people, redirect them to static waiting room. Okay, and it doesn't. Okay, that helps. I mean, there are some. So your requests are going to some distributed networks or some distributed servers which are close to user's location and which can run some scripts, right? Generally they are used to serve some static assets, but here we have put on some scripts on this. Okay, so how's the queue status of the user maintained, right? That is the important part. Okay, this 2 million people in the queue, we cannot insert 2 million rows into SQL. Yeah, of course. Okay, to track them, okay, maybe we can, but 2 million is not a lot of records, but I think it's just an example. But yeah, it depends on how long do you have, right? If you are trying to do within few seconds, then yeah, of course it's not something that you can rely on. Okay, extremely lightweight. We need a mechanism that is much lightweight and uses a combination of distributed counters or something. Okay, the user sends a request to this thing, edge interception, the sale is hot. Okay, atomic counter. CDN gives this user a unique number. It reaches to highly optimized Redis cluster and read counter. Okay. Instead of storing this number, the CDN wraps this into an encrypted cookie and sends this. Cookie contents encrypted. The state of user position now lives in, not in your database. The cost 0 in your memory. Okay, so this makes sense. So they have some mechanism of initially assigning a queue number to the user, which is also maintaining the joining time. And then yeah, we don't care about it as long as the user has been given a queue number. That's good enough. Okay, and user keeps with them, and they are saying encrypted, and I think that's where also JWT would come into the picture, because we need this so that nobody can modify these my numbers. So this is one question that we want to understand: how the queue number is returned so that it cannot be modified by the users. Okay, the user is now looking at the setting. Okay, they are in the line. The waiting room has tiny JavaScript code. It prints CDN edge. What numbers are you currently printing? Okay, the CDN edge cached value from Redis that tracks front of the line, exactly serving counter. Okay, so there is one question here that I have, like how does CDN know what is the latest number that is being tracked? How does the CDN know what is the serving counter? Most likely it is somehow talking to backend, and CDN servers are refreshing those. The browser receives this number, looks at your own cookie, compares. Okay, JavaScript calculates there are 50,000 people ahead of you, and yeah, so that's how you know. And if your number is later than this one, then yeah, you know the people ahead of you, otherwise you're just let in. So this is the translation holding pen to active site. Okay, the user polls the CDN again. What's your queue? Queue is now serving up to 451. Okay, my number is this, less than access request. The browser automatically sends a request to the CDN endpoint. I'm ready to enter. Here's my encrypted cookie proving that my number is one. Okay, then you get the golden ticket that users didn't fake their number. Okay, this JWT contains, okay, bypass pass. It seems like this, and then okay, so I think we now need to understand what is JWT as well. Okay, the handoff. CDN redirects this, so you get the JWT, you are redirected to the checkout. Okay, and crossing the mode, and then each request would sign your JWTs. Finally allowed this. Okay, so these are the three important questions that we have now after reading all what it said. If you have any more questions, you can post in the comments as well, so I can also learn more the questions that you think about, or try to answer it to you by myself. Okay, let's see. How's the queue number being returned so that it cannot be modified? If you just set a browser cookie, change the queue position to end, skip one point. Of course, you want to prevent this, right? So vaccine in the artificial document before you can the secret key. The CDN server possesses a private high entropy secret key that only it knows. It never leaves the server environment and calls secret key, the data payload. When the user arrives, CDN determines their queue number is this. It creates a JSON payload, and then it would, I think, sign that with this key. So the result is a unique string which is signed, the signed cookie. The CDN sends a cookie to the users containing both the data and the signature, usually in the period. Okay. Secure so that it only travels by HTTP. Okay, so basically what happened is that the CDN server somehow fetched the queue number and the event ID and the queue number for the event ID. It created a signature by signing that via a private key or this secret key essentially, and then yeah, those secret keys. So I just have one question: is it safe to store secret keys on CDNs? I don't know that. I'm thinking, because another approach, as I was reading before here, can be that the backends could generate these keys based on the signatures based on the private keys, and the CDNs can use public keys essentially to verify the requests that are coming from the user's browser. So let's understand this even better. If that is the only way, is it the only way to maintain signatures? Okay. And the next thing here is that the verification, right? So when the user tries to refresh or do something or try to check the status, they get the CDN receive the signature. And of course, users cannot modify this because they don't have the secret key. If they do try to modify the signature, then it gets corrupted, and then CDN takes the incoming data, runs the exact same process, verifies the signature should be generated. If they match, the data has not been tampered with, and the queue number is genuine. Okay. How does the CDN know what is the serving counter? Okay, so this part I think is clear on how that secrets are being maintained. So somehow the queue number is being signed via secret key, and that cannot be tampered with. This completely makes sense. How does the CDN know what is the serving counter? Okay, we have thousands of CDN nodes and one central application in the backend. If CDN node, what are you serving? Every time you serve, we would have. Okay, so centralized high-speed truth with edge caching. It holds a single critical key integer and it says value is 2000. Your backend application service are processing the ticket sales. It increments the key in central Redis. Okay, we process 2000 people. Upgrade serving up to. Okay, this is about the serving counter. Yeah. Okay, so some backend process is modifying this key that is being served. So the number that is being served up to, and that number is stored in a Redis which is being served. A user polls the Tokyo CDN who's being served. Tokyo CDN checks local memory cache miss, it doesn't throw. Make quick request to central to get the number 52,000 cache set. If the Tokyo saves this TTL for 15 seconds. 15 seconds, every other user in Tokyo gets the same cached value without touching the central Redis brain. Okay. The global state propagates out every 15 seconds, the load on the central transmission. Okay, so regardless of whether 100 users or 100,000 users are waiting, 1,000,000 users are waiting. This totally makes sense. Yeah, I do not have any other question. My only question is that how do you get the queue number, right? So yeah, this is currently serving up to 52,000, but how do users get the initial number? So is there the same process going on? Like, okay, if there are so many just users logging into the queue, then just the number generator, does it crash, or how does that number generation happen? And also we must make sure that all the users globally get the unique number. So it's at least one request that needs to come to your backend to give the users the number. So let's learn about it as well. And finally, the JWT. Okay. CDN is the guard that maintains the line. Your backend is the code. When you reach the front gate, the security guard doesn't wake all the way to the roller coaster, introduce you to the operator that doesn't scale. Yeah, so instead security guard puts a wristband on you. You walk in, when you get to the roller coaster, looks at your wristband, well, right. Because they trust the security guard who put it on. JWT is that wristband. Okay, so it has 3 parts. And the header, that this JWT has been signed by this algorithm or anything other metadata regarding the JWT. The payload claims, which contains the expiry, past queue. Okay, some information about the user, and short-lived. So if user goes eating lunch, they have to requeue. Okay. Exactly, and the signature cookie game maintained in the question 1. So CDN uses the secret key and the header to maintain the payload. So I think it's the same kind of process that we already understood in the first question, that the data is encrypted by an algorithm that can only be matched. Basically, they match the signature of the data that is being passed to the signature that is being sent by the user as well. So the signature should essentially match. Okay, so this was okay. So let's try to get answers to our questions essentially. So this, I think, gives you some basic idea on how authentication is also working in modern applications. Like, how do you verify that the users are legitimate. And JWT, I have come across it multiple times, and I think it's a very, very important concept to understand with. So let's go deeper into the security mechanisms and the crucial. Is it safe to store CDN service? This is a classic secure performance availability. Is it safe in the world? Distributed safe is a related term. Okay, CDN secret key, secure dashboards. Is it the only way? No, it's not the only way. Okay, they say that there are very, very low risks of storing the keys. Okay, asymmetric cryptography. There is public-private keys. Instead of sharing the secret, you could also use the private-public key pairs. The entity that creates the signature needs the private key, and this inner CDN needs to create the signed cookie. Therefore, CDN must hold the private key. This doesn't solve the security concern. Storing a private key at edge is same as secret. Okay, centralizing the signing, high security approach. If you don't want to store your secrets on the edge, then CDN makes the API call to the backend, the signer service, which holds the secret key, generates the signature for the payload, and returns the request. So you have reintroduced the network round trips and the central point of failure for every single user at the queue. At 2 million concurrent user, your signing service will have to likely fall over, and you basically beat your point. So this totally makes sense to me. Like, yeah, there are some trade-offs that we are doing, given the chances are very, very low to get this key leaked somehow. I think it's acceptable. Okay, and then we have the alternate approach that we understand as well now. But okay, now the second more important question is, we established that we cannot insert the root because of the 2 million simultaneously writes will lock the database. We need a better system. Okay, Redis is an in-memory store crucial thread. If 10,000 different edge servers sends increment counter to same, Redis will queue them up, execute them one by one, and sequentially first. There are no race conditions. Every requester gets a unique integer. So I think Redis is what's playing a key role here. If you want to know more about Redis in a separate video, then let me know in the comments and we will dive into that, just like we are doing right now. And I hope you are having fun, because I'm at least enjoying this a lot, understanding how we are just talking about the first problem, like how to prevent your infrastructure from being overloaded from so many users. This is super interesting. Edge interception, the log data safe is okay. The step-by-step flow. User clicks the link, HTTP gets, CDN receives, sale is active, user has no tracking cookie. Okay, they call oracles. Atomic magic. Okay, processes or requests, current counter, it is okay. State, CDN receives. Okay. So I think it's more or less clear. Instead of, if you anticipate level of load, we should count. Okay, it's extreme scale. Redis bottleneck is Redis instance can handle increments per second. If you have 2 million people hitting within 1 second, even a single Redis instance might become a bottleneck. So you need to have something better. So instead of one key global counter, we create 10 Redis counters, 0, 1, 2, 3, and then CDN, it randomly selects a shard. It sends a counter 3, Redis returns this, CDN calculates the number of queue, calculates the actual number as plus 3. Okay, because you had 10 Redis counters and what is, okay, plus 3. So if you, let's say, returns 1, then you would have 10, which of them was randomly selected. So basically you're trying to distribute the load across multiple shards or multiple instances of Redis and combining the returned responses in a sense that you can have a unique key across. So if it was, so this number is going to be unique, always 0, 1, 0 to 10, and this can be duplicate. So the sum is, I think, going to be okay. So if both of these return the same number, 1 and 1, so you would have 10 plus 1 and 10 plus 2, 12. There is no other way you could generate 11 from any of these, because that would be different, because you will be adding so if it goes 1 to 10, 0, 1, so this would be generating the numbers kind of. Yeah, okay. So now I think our first problem of how to prevent the users from thrashing your application and how they control it is kind of cleared, right? We are using JWT, we are using some Redis to increment the counters and maintain the counters, to do those atomic operations at a very high scale, and those are then handled by the content delivery networks. And when the user and the content delivery networks are being continuously updated. So what's kind of going on here, if I can try to summarize this, is that when a user logs into the website, CDN basically fetches the number from the backend about the queue position that the user is on using a Redis. The response is returned as a signed JWT to the user or a signed token, whatever. That token is verified upon every call. The CDN networks are constantly checking what is the queue number that is being served right now. If the user falls within the range of the users being served, they are given a new JWT which grants access to the APIs, which then users can use to move ahead in the process of booking the tickets. And then we understood about JWT, private key, secret key mechanisms. Very, very interesting stuff that's been going on here. So, okay, that was the first part of the problem for understanding how 10,000 people are, or how millions of people are actually prevented from entering the website at the same time, or prevented from booking the tickets at the same time. I'll see you in the... So it's already been 20 minutes more or less that we've been spent on the first problem. I think I will do a separate video on the part 2 of understanding this problem in depth. Make sure you're subscribed to this channel right now.